Hello, I am Tatiana Marugo Jimenez, a student at the National Open and Distance University, UNAD, in the School of Industrial Engineering. In this presentation, we will cover Phase 4, Non-Parametric Tests, from the Statistical Inference course. In this video, I will explain how non-parametric tests are applied and interpreted, which are fundamental when we cannot assume a specific data distribution. Throughout this presentation, we will analyze various practical exercises related to these statistical tests. Problem description. The problem addressed in this study focuses on evaluating data from different variables without assuming they follow a normal distribution. This situation is common when data normality cannot be assumed, which makes non-parametric tests necessary. Through this analysis, we aim to determine if there are significant differences between the distributions of the variables in question, despite the lack of a known distribution. Database. The database used for this analysis contains information collected from different urban areas, with variables such as city zone, particulate matter level, PM10, day of the week, among others. This database is essential for applying non-parametric tests, as it allows us to observe how the variables are distributed and whether there is any relationship between them. Sample. The sample used was extracted from a total of 8,130 records, randomly selecting data from different days of the week in areas of the city. From these records, 706 representative elements were chosen to ensure an adequate sample reflecting urban environmental conditions. Through this sample, we aim to effectively represent the distribution of particulate matter in urban areas. It is important to highlight that, because the data do not follow a normal distribution, the use of non-parametric tests is necessary to analyze these results. Introduction to non-parametric tests. Non-parametric tests are useful when data do not follow a normal distribution, or when samples do not meet the necessary assumptions for parametric tests. These tests allow us to analyze independence, similarity between distributions, and differences between groups without making strict assumptions about the data distribution. Some of the most common non-parametric tests are the chi-square test, Kolmogorov-Smirnov test, Kruskal-Wallis test, and the contingency test. Chi-square test. We begin with the chi-square test, which helps us determine whether a categorical variable, such as city zone, is evenly distributed across different categories. In this exercise, a chi-square value of 2,800 was calculated. By comparing this value with the theoretical critical value of 7.815 and considering a significance level of 0.05, we conclude that there is not enough evidence to reject the null hypothesis. This means we cannot claim that city zones have a non-uniform distribution. Kolmogorov-Smirnov test. Now let's move on to the Kolmogorov-Smirnov test, which checks whether a variable, in this case the time range, is uniformly distributed. In the exercise, the value of the test statistic was 0.2000. When comparing it with the critical value, we do not reject the null hypothesis. This indicates that the time range data is uniformly distributed, meaning all categories have the same probability of occurring. Kruskal-Wallis test. The Kruskal-Wallis test is used to assess whether there are significant differences in the medians of several independent samples. In this exercise, PM10 particulate matter levels were compared across different city zones. The value of the H statistic was 27.457, which is greater than the critical value of 12.838. This leads us to reject the null hypothesis, indicating that there are significant differences in PM10 levels across the zones. Contingency test. Finally, the contingency test is used to determine whether two categorical variables are independent. In this exercise, the relationship between the day of the week and the most abundant particulate matter was analyzed. The value of the test statistic was 13.682. When comparing it with the critical value of 28.864, we do not reject the null hypothesis. This suggests that the two variables are independent, meaning the type of particulate matter does not depend on the day of the week. Conclusion. In conclusion, the non-parametric tests we have reviewed are powerful tools for analyzing data without needing to assume a specific distribution. Through the examples of chi-square, Kolmogorov-Smirnov, Kruskal-Wallis, and the contingency test, we have learned to interpret results correctly, making informed decisions about our hypotheses. I hope this video has been helpful in understanding how to apply and analyze non-parametric tests in practical situations.